Welcome to session 7, Qualitative Analytics Capabilities using NLP. So before we get started, I do want to share a few reminders. So as our speakers present, please remember to stay muted to minimize distractions. If you have a question during the presentation, please submit it using our Zoom chat. At the end of our session, all of our questions will be answered by our session speakers. And as I said during our last session, or if you're just now joining us between meetings, our questions will be added to a Q&A page linked in our Confluence space. So please be sure to check out there so you can get any other questions answered that might not have been covered during the session itself. This session does have a notebook available. The link to that is going to be dropped in our chat by Laura, so keep an eye out there so you can access it during the demo portion. And with that, I will pass things over to Nikhil to give more information about himself, his background, and his presentation.
Yeah, thank you so much, Julia, and good afternoon, everyone. Thanks for joining in. And Sarah, thank you for the great presentation before this. My name is Nikhil Nirale. I'm the Chief Data Scientist for CCSQ AIM. AIM stands for Artificial Intelligence through Machine Learned Modeling. So that's where the data science connection comes into picture. I've been dabbling in the field of data science for about the past 6 to 7 years now. It's been a very exciting time for data science and machine learning in general. So very excited to share all the findings with you guys today. So Julia, please, if we can go to the next slide. Okay, so the couple of things we are covering today, a slight background about AIM, what AIM is and what it does, and then we'll get into how we go about developing an AIML solution. And since large language models, generative AI is kind of the new thing that's happening. So we'll talk a few things about that. And then we have a demo in place to go through some large language model fine tuning. Okay, so to start off with the AIM background, AIM has two use cases at a high level. One is analyzing text data that comes in through policy feedback or policy proposal feedback. So, which is where a lot of text data comes in, and you can use machine learning and natural language processing to handle and analyze and build solutions around the data. The second use case is the nursing home 2567 data. This is the data that comes in from nursing home surveys that are conducted across the country. So a lot of data coming in as part of these use cases in a regular time period here. So won't go into too much details about these things, but please, if anyone is interested about any of these use cases, please feel free to reach out to the AIM team here. Yeah, Julia, can we go to the next slide? Okay, an overview of the first use case, which is FAS. A lot of features that we have built as part of FAS. It's an AIML powered system. All these features are available in the application right now. The team and the stakeholders have worked together to kind of bring this into reality. So again, I won't go into details of each of these features, but a lot of features have been built out in the last couple of years. So if any of this looks of interest to you, we can please reach out and we can talk about this. Julia, can we go to the next slide? Okay, now the models. This is kind of the highlight of what we have done as part of FAS in terms of machine learning. These are all the models that we have developed. These range from themes, identifying stakeholders, identifying sentiments, recommendations, clarification, identifying duplicate data, identifying or mapping topics to like mapping comments to proposal topics. So all these models ranging from supervised to unsupervised approaches have been implemented as part of FAS. And as I mentioned, it's like to solve a specific use case. You can use anything. It doesn't have to be supervised approaches always, but unsupervised approaches also help a lot sometimes. Julia, next slide, please. Okay, this is the second use case, a high level overview. As I mentioned earlier, 2567 data is something that is generated through all the nursing home surveys that are conducted across the country. This is about the data sets that we have right now include more than 500,000 rows. So a lot of data to process here and do some analysis on this. So this is under development. This is something that started off like, I think about 7 months now. So this is kind of a new thing that we are doing. So a lot of interesting things going on here. We are building a couple of models as part of the 2567 analysis as well. For that, can we go to the next slide, please? Okay, these are the couple of models that are under development right now. They are maturing as we speak, actually. So, and since this is new and kind of coincides with the new large language model utility that has been going on, we are evaluating how we can utilize large language models for these use cases. But that's something under evaluation right now. We are making progress on this, and hopefully, we are able to kind of deliver some good models as part of this use case. Next slide, please. Okay, now this is like how do we go about building an AIML solution workflow, or at least what we have done as part of AIM to build an AIML solution workflow, and we want to share those findings about what has helped us. One of the core principles that has always been in our mind is AI should always be an assisting tool and not a decision-making tool. So that core philosophy is very critical when you're trying to build an AIML solution. And the couple of areas that are around this core philosophy, like understanding requirements, converting those requirements into technical requirements, model training, development, all of this, once you look at it from an assisting tool perspective, your perspective about how you develop or how you go about improving things also changes. So that's why the core philosophy is AI is an assisting tool and not a decision-making tool. And this is a loop. You kind of go into this iterative development and improvement loop, but you want to get your model into production. So that's what we have in the right here. You constantly work with the end users, with the whole team about how the utility will show up for a certain model, how you will visualize the outcomes, how you can improve the models. This process kind of keeps going on in cycles, and that's where you see improvement, but you do want to get your model into production as soon as possible. And once that happens, a couple of other areas in machine learning which have to go along with the model in production, with these are like model monitoring, feedback mechanisms, so that you can keep collecting new data and new information so that you can be up to date with the way a decision is made. Then there is ML operations, so that you can have all these processes of training, deployment automated. And then there is responsible AI. Responsible AI has been a thing since before, but since the recent guidelines that have come out from the White House and the HHS AI guidelines, it has become a very critical thing right now. So this is something that we are working towards incorporating into our current systems. Next slide, please. Okay, so just going through each of these steps at a high level, understanding business requirements. I think it's the most critical step. And as I said, the philosophy is to use AI as an assisting tool. So here is where understanding how the business works and how the processes work is very critical so that you can map those processes using an AIML solution. So very critical step. Understanding how the business works kind of defines how you build your models, your choice of models, the choice of data. All these things are determined by this step. So pretty critical. One thing that has helped us a lot is having documentation and educational material in place to provide transparency on AIML topics. It's a very rapidly changing field. So the documentation and educational material, having those updated definitely helps a lot. So this is something we have been improving on, and we'll keep improving on this. Next slide, please. Okay, business requirements analysis. This is, I mean, something we have already done. I mean, all of us have kind of been kind of through this step of understanding business requirements. But one thing that stands out for an AIML solution is there is a certain research-oriented approach that you have to take for an AIML solution. You always don't know what will work best. So that's where you have to figure out, and there is some research associated with that approach. And that's where understanding these business requirements in a proper sense helps you to understand how much research and what are the unknowns that you need to figure out here before you start building a solution. And that's where that focus on identifying those pieces where some research or figuring out is needed, or just trying out various things is needed. That's good to understand beforehand so that you can plan things out properly and identify the right risks in terms of getting things done. Next slide, please. Okay, now you get into the conversion of business requirements to technical requirements. So one very important question that we ask ourselves is like we don't want to do AIML for the sake of AIML, but can this be solved in an easier manner is something that we always ask. And if that's a yes, it's I mean, it's good to keep good to keep things simple always. But so that's the first question to ask. But if you see that AIML solution is actually needed, then you get into the determination about do you want to go for a supervised approach? Do you want to go for an unsupervised approach? And what are the implications of each of them? Unsupervised approaches are, since they do not involve a lot of metrics around it, but do require qualitative evaluation for sure, are simpler in nature. But supervised solutions, when you start training models, you look at a lot of validation metrics, a lot of training metrics. You have label data, and then how you are performing on the test data set. All these things come into picture, and then of course there is a feedback mechanism. So that's why that evaluation of what kind of solution is needed becomes critical. And whenever you go for a supervised solution, we, as part of FAS, we've had a lot of instances where we have used a supervised approach. So that's where we had to gather label data. So we had to define what the label should be, how would we collect it, what would be our tool of interest to collect the labeling data, and how would people be involved so that we collect good amounts of labeling data. So that's where all of these things come into picture. But definitely once label data is collected and you see a model working with that label data, it's a kind of an achievement to work towards for sure. And need for data augmentation, there can be a lot of data sources that can help improve your outcomes. So identifying those also help. One of our models, which is like the stakeholder model, looks at the CMS provider tables for some lookup kind of a process. And that has helped to improve our processes a lot. So identifying those data sets in the first place helps for sure. Then the final part is the resource and cost estimation. This is kind of, I would say, um, a generic step everyone would take, but so same thing applies to an AIML solution as well. Next slide, please. Okay, so now all these initial pieces are done. We want to get into model development. So that's why I've chosen a case study here that we implemented as part of AIM. This was to identify dark statements. Dark means disagreement, agreement, recommendation, and clarification statements within a comment. And this is very similar to sentiment analysis problems, but it has a slight twist to it, which I'll get to on the next slide. But this required, we undertook the previous steps that I mentioned. We identified we need label data for this. We set up labeling jobs using SageMaker Ground Truth. The AIM team, external labelers, end users contribute heavily to the labeling process, and that generated some decent amount of data to start model training. Julia, next slide, please. Okay, so this was the use case. Now, on the left, you can see a block of text. Usually, whenever you go for a sentiment model building problem, you would be like, let's take in the whole text, assign it labels, and you get a sentiment as positive or negative. That could work, but a couple of issues you would have with that, you wouldn't know where the model is looking for information to make a certain decision about a label. So that's where, and this was something that we identified as part of our requirements gathering, is that given this text, we saw the end users were making a conclusion about a recommendation or an agreement by looking at specific statements in this text. You can see those highlighted as recommendations, and there is an agreement also. So basically the analysis or conclusion was done using sentence level data. So it was not like a full text problem, but sentences within a text problem. So that's where the labeling effort went into, of highlighting sentences of interest across multiple comments, and it created a data set very similar to your right here. You can see the first statement is a recommendation, next is a disagreement, third is an agreement, finally fourth row is a clarification, and then fifth row is all the other statements, because you have your statements of interest in the text, but what do you do about the rest of the statements that are showing up in the comments? So that's something we bucketed as other or generic statements. and created this additional class so that we can sort out those generic looking statements out of picture and get to the statements of interest. Next slide, please. Okay, so once this data set was collected, we utilized a BERT text classification model from SageMaker Jumpstart repository of models. If you go into the SageMaker Jumpstart repository, you'll find a lot of models ranging from text classification to Q&A analysis, then sentence matching, sentence similarity, and various types of architectures are also available. We went to go with BERT as it's one of the most uh, famous or well-known and very well-established architectures, but a lot of other architectures are available as well, like GPT is also available through SageMaker Jumpstart. Now, once the choice of model was done, we went into setting up hyperparameter optimization jobs to tune for maximum accuracy. And specifically, we were optimizing on the learning rate and the batch size. Now, there's about 16 hyperparameters that you can tune as part of BERT, but learning rate and batch size are something that is recommended by the BERT authors to start off with. So if you don't get good performances using learning rate and batch size tuning, you can definitely try a couple of other ones like L1 and L2 regularizers and so on. So after doing all of this hyperparameter tuning, we achieved a validation accuracy of 90%. So that looked good enough as the first version. And for the inference process, we hosted the model as part of an SageMaker batch processing job. Now, one thing that we have as part of AIM is that data frequently comes in during a live policy proposal analysis. So that's where this whole process had to be automated. And we used a setup of AWS Lambda and AWS step functions, which consumed this batch processing job to run it in an automated manner. Next slide, please. So there were a couple of challenges that we saw while the model development phase. We wanted to identify how the model sentences that do not fall in the required label categories will be handled. And that's where we came up with the idea of assigning all those general statement as a generic label. So it created a fifth additional label in our training data set. So that basically, now since you are conducting your inference at a sentence level, you would want, when you come across a generic statement, you would want it to be labeled as generic in nature, right? So that's where the additional label helps you out in your model inference process. Now, the second challenge was the variation in the distribution of labels. Now, generic statements are definitely going to be a lot in number, but the recommendations were higher than disagreements as compared to agreements in comparison to clarifications. So, and generic were like much higher than all of this. So, how did we take care of that issue? Was we developed a two-step model here. The first model was a binary classifier that differentiates between generic versus dark. Just two classes here. And once a new statement is inferred as dark, it goes into the second step, and then the additional breakdown with as a disagreement, agreement, recommendation, or clarification is handled by the second multi-class classification model. So that's how we were able to incorporate all the data, but also get decent accuracies using a two-step process. The third challenge was scalability of the inference process. Now, the comments that we get during each proposal are like in thousands of numbers. And now you break those comments down into sentences, your data kind of goes up by 10 to 20x times. So that's where you have to make sure you have a process that's good enough to handle these many sentences. So this is where we utilize data parallelization techniques available as part of SageMaker and AWS in general to improve the inference time for all comments. And this is something we have improved the time, but we are constantly looking into ways about how we can make the time to execution much faster. Next slide, please. Okay. So final step, yeah, definitely like as you're doing these things, always like the communication between the stakeholders is very critical, showing what you have done, gathering feedback about how things are working, how the results are showing up, helps to improve your solution. So that is definitely one of the critical areas of this whole solution building piece. Next slide, please. Okay, so this is a screenshot of FAS. This is how everything that we talked about in the couple of slides before has come together. You can see there are highlights of disagreement, agreements, recommendations, and clarification. So our UI, UX, and HCD teams have done some great work bringing this all together. But one thing you'll see there is at the center, you'll see select to add an annotation box. That's where you can add your own annotations. And on the right here, on the bottom right, you see there are some cross signs associated with each of the sentences. Like you can see a cross sign on the left of recommendation labels. That's something you can use to just remove any identification that has been done. So this is kind of that feedback creation or feedback mechanism has been set up to for the end users to provide any feedback or change what they are seeing. And of course, the input that they provide can be further used to retrain the model for better understanding of the use case. Next slide, please. Okay, this is how this whole system looks at a high level. It starts from the left here, but there's always a data collection pipeline. The data collection pipeline feeds data into your labeling jobs. The labelers will go through labeling, and then that data, of course, there is some data processing that's involved. You cannot pick up the raw label data as it is. You have to do some processing, and that's when it's written out to S3 buckets and it's picked up for model training. Now we are at the center box here. The model training is, as you do the model training, you keep evaluating it for sure, and it's recommended, and it has helped us to use having test data sets available to do your model evaluation. So if your model's performance fits into your criteria that you have set on the test data set, that's when you can decide to move it to production. And if not, you can go back and look into what's happening wrong and keep kind of iteratively training your model. And once you get into model deployment, that's where you can choose to go for an endpoint or a batch processing job. An endpoint can be easily integrated into any interface. So you can go that way. Or if you go for a batch processing, once you complete your batch processing jobs, your data can feed into a data layer, which is consumed by a UI. Now, as we mentioned in the previous slide, the UI has a feedback mechanism in place. But one thing we did realize during the development was directly using that feedback into your model training isn't the best idea, because it could happen that there is a certain prediction, but two users have different opinions about it. So that's where validation dashboard comes into picture. You can see at the bottom of your screen, and that helps to basically identify these cases where there is discrepancy in judgment of what should a certain prediction be. You can catch those. It's a really good thing because you can go back to the end users and talk about this, like what should be the right prediction here, and that helps in general to improve the system and understanding of the model. Next slide, please. Okay, so this is something that we have been doing in the present. What's in the future? What's the next step here? So it's definitely large language models is very something to consider about how to incorporate into current processes and how to build new processes. But a more critical factor is how you develop AI solutions responsibility. There's bias, there's hallucinations, all these terms that have come out in the recent years. You have to have good responsible AI development frameworks so that you can navigate around these issues. Next slide, please. Okay, so regarding the use of large language models, we are currently evaluating all these techniques that are bolded up here. First one is few shot learning. This is, I mean, a lot of you must have already heard about this, but this is just giving a few examples to the large language model, and it will start predicting or start giving you responses based on your given inputs or given examples. Now, this is something we have started evaluating as part of AIM, and I can tell you, like, a lot of regular expression code can, like, one case I can tell you 50 to 60 lines of regular expression code was literally just solved using 30 to 40, sorry, just few lines, I would say 10 lines of examples into a few short learning process, and it started giving out very similar results to the regex process that we had. So a lot of capability in this area to automate these small uh, processes that we have as part of code. Then we have domain adaptation fine tuning. As the name suggests, this is adapting your large language model to understand domain specific data, and so that the responses that it gives out uses it has accurate content in it, right? Then the next step is instruction fine tuning. This is slightly different, and domain adaptation fine tuning and instruction fine tuning involve model training. Few short learning doesn't involve model training. It's something very specific to your current session that you're working on, and that's something that will go away once your session is over. But domain adaptation fine tuning, instruction fine tuning does use model training in the backend. It tunes the weights of the model to generate the right response. Instruction fine-tuning is this very interesting one because you can change how the model responds to your questions. So it's slightly different from domain adaptation, but it's kind of changing. So if once you ask a question, if you want the response to be in a different manner, so that's where instruction fine-tuning can help you. And we have a demo regarding this coming up in a couple of minutes, but we'll talk more about it then. Okay, next is retrieval augmented generation. This is also a pretty, sorry, Julie, I was just completing the last part there. Okay, thank you. So next is retrieval augmented generation. This is one of the famous use cases that has come up in the recent years. This involves building a chatbot, a text to SQL chatbot, or a text to SQL kind of approach. Chatbots are essentially you provide in a text and it will respond back to you with a text. But RAG comes into the picture here by connecting external data sources into this chatbot framework so that you can use a large language model combined with your external data sources to give out information while you are using the chatbot interface. Text to SQL is an interesting one. Again, very similar to a chatbot, but now instead of giving text and getting back text, you are just giving it text, but getting back tables. Or if you can get back tables, you can also get back charts. So in this process, instead of talking to documents, your large language model is basically talking to tables in the backend. And you can generate SQL queries, run it on the tables, and it can give you back tables as a response. So natural language query to table as a response. And if you're generating tables, you can definitely create charts out of it. The couple of tools and technologies that we are using here are SageMaker, Jumpstart, and Bedrock. Jumpstart has been around since some time. Bedrock is still in FedRAMP approval, but we are keeping a close eye out on what we can do with Bedrock here. Next slide, please. Okay, responsible AI development, a very critical side. We operate in accordance with the White House directives and the HSS AI playbook for responsible AI development. The guidelines have come out a couple of months back, so we are in the process of incorporating this into our current systems. The guidelines summarize things at a high level. A more in-depth evaluation is, of course, needed to adapt that to your use cases. So that's something we have been working on and should be part of our documentation and slides in the couple of upcoming months. And as part of the AIM roadmap, responsible AI development is being incorporated in two parts. One is building governance, transparency, and evaluation frameworks around existing models. And the second one is evaluating tools, technologies, and frameworks around large language model development. Okay, Julia, can we go to the next slide, please? Okay, so the first point regarding building governance, transparency, and model evaluation frameworks around existing models. So FAS, as I said, has been in place for 2 years now. So it's been existing, and that's where we want to figure out how we can improve on the governance, transparency, and model evaluation pieces of this. So we have already begun some work on that using explainability tools like SageMaker Clarify, and we are standardizing the use of Clarify as much as possible so that when you give it any new model which does predictions, you can easily get an analyzed Excel file or something like that, which can be used to explain the results of predictions. Another thing that we are working on is enhancing documentation to provide greater transparency into modeling processes. This is something ongoing, constantly improving on as we get input about what we should be doing and how to create documentation around it. We are also in the process of setting up an MLOps framework, which will include better model governance and data governance. And that's where we are utilizing the SageMaker model repository and model cards and all the features that these services provide to improve the data, to improve the governance pieces. So the second part is evaluating tools, technologies, and development frameworks around LLM development. So this is something of like the new thing that's coming up here. So this is my opinion, open source large language models first is something to start off with. I'm a fan of open source LLMs, but I cannot have personal choices here. Definitely an in-depth evaluation is needed for what works better, but open source large language models is something to start with due to the security concerns associated with a closed model, but further evaluation is of course needed to determine what works best. Okay, then we have Amazon Bedrock, which is kind of the new service that has come out for large language model and further development. It has a service called Guardrails for content moderation. So a pretty interesting thing to look into. This is something we are currently evaluating. So, and the last one is utilizing metrics-driven development and test-driven development into LLM usage. This is very critical, in my opinion. Metrics-driven development, like when you are using a large language model, it generates certain predictions. You want to make sure before you incorporate LLMs into your operational processes, it should achieve certain accuracies for what you're trying to what outcome is being generated. So you can go with some label data or collect some relevant data based on your use case and make sure that the model will go ahead only if you go beyond certain thresholds, right? So like for example, the regex case, we do have some label data collected. So even if we are doing the regex using an LLM, it will be evaluated on the label data that we have collected so that we achieve the right accuracy threshold and then go ahead with the large language model usage. So next slide, please. I think it's the demo. Okay, thank you. So the demo is about improving response alignment using large language models. So I can start sharing my screen. Okay, can you see my screen?
Yep, looks good.
Oh, thanks, Julia. Okay, so what's this notebook about is, so this is about instruction fine-tuning, how you can do instruction fine-tuning using a Llama 2 model specifically. And the applications of instruction fine-tuning are pretty interesting. It has a lot of applications. This is something we'll get back to at the end of this notebook. But we are using Llama 2, 7 billion parameter model here to conduct instruction fine-tuning, just some initial steps. And just to mention this, I'm sharing this as part of my SageMaker notebooks, but this notebook is available as within the Databricks environments, which I think Lure has already shared the link for. So initial steps involve just what do you say, just setting up an endpoint and conducting certain inferences on it. So as you could see, the endpoint has been set up and you send it a specific question that tell me a few highlights about Madonna's impact on pop music, and it will return with a certain response. But what you want to try to do here with instruction fine-tuning is that maybe you're not happy with the way the large language model is returning the information back to you. You expect the response to be in a certain way. You can maybe want it to be more neutral or maybe short and so on. You can do this through prompt tuning for sure. You can specify the kind of output that you want in your prompt. But if it goes beyond that, that's where you'll have to consider training or instruction fine tuning a large language model. So that's what we will be covering here. So we have a data set in place already, and it looks something like this here, right here. You can see there is an instruction, there is a context right here, and there is a response. This is kind of the format that you usually have in a chatbot interface. You give it an instruction like summarize this content for me, and the content is the context, and you get back a response. So a similar format will be required to fine tune a large language model. So the data set has already been set up that way, and this is what you'll pass in to your large language model for the learning. A couple of data preparation steps. Now, usually all these deep learning architectures have some preparatory steps that you need to do, like setting up tokenizers, setting up the right optimizers, so all these things. So AWS does this, makes this easy for you. All this is handled in the backend. All you have to do is make sure you put in the data in the right way, and the rest of the things are covered for you through the through the deep learning containers that are available as part of AWS. Okay, you upload your data sets to S3, again, a data preparation step, and now you start training your model here. You have put in the data based on the required format, you set up the model IDs, versions, environment. This is something of a requirement. So um, that's you have to set this as true. And a lot of other parameters, disable output compression. It's related to, do you want your model to be come out as a compressed output, as a compressed model or a decompressed model? That's your choice based on your requirements. But this is these you do have various options to set up how the model is stored, how it's tuned, and so on. And of course, a lot of hyperparameters that you can tune on. This is something you can experiment with as you go about looking into the metrics for a specific training job. So once you start the training, your training job will start, and this all these blue things is something you don't have to be on your SageMaker notebook for this. The training job will begin as part of your SageMaker environment, and you can completely ignore this part. You can just continue with what you're doing, and your training jobs will take place in the backend. So nothing to worry about here. I'll just clear this up. Okay, once your estimator.fit is done, that basically says that your training job is complete. You can go back to your console and look at some of the training jobs. So I'll just show you an example here. Sorry, I think my teammates are working on a couple of training jobs here. But yeah, this was the training job that was completed. So all the information can be viewed here. Okay, so now you deploy what has the training job that has been completed, you deploy it into a model. So now what we want to do for the same given question and context, we want to see how does the pre-trained model respond and how does the fine-tuned model respond. And that's where this table comes into picture. So a lot of things happening in here, but something interesting I can show you. Now, this is generating a lot of response, but that's because I'm using a base model. But if we go for an instruct version of the Llama 7B, you'll definitely get some more improved output. But if you just look at the response here, and please stay with me here, you can see this response. This is from the pre-trained model, no fine tuning involved here. And you can see the response says the right side of the brain is responsible for the left side of the body, and the left side of the brain is responsible for the right side of the body. So not the best way I would want an answer for. So the new fine-tuned response looks something like this. The right side of the brain is associated with creativity, intuition, and emotion. The left side of the brain is associated with logic, rationality, and analytical thinking. So you essentially changed how the model is responding using a new data set. And how does this help, right? This is a good example to demo, but how does this actually help in reality? So one thing we already covered is you want your responses to be aligned to the expected output. So a pretty obvious thing here. But now what you can do is migrate your legacy ML workflows like entity recognition and classification onto an LLM, because now you have this format of asking a question given a context and getting a response. You can change that to something like, okay, what are the entities in this text? You give it the context, and the output will be certain entities that come out of your question. So if the model was previously just identifying random entities, after fine tuning, it will identify entities that are of interest to you. So that's where you can migrate all your previous ML workflows, entity rec, and it's funny I'm calling this as legacy workflows because it's due to large language models, it's kind of looks legacy right now. So but you can move all your previous use cases onto an LLM. And you can do this for multiple workflows and multiple models. You can use one model for everything. You ask it a question that do classification for me, it will respond in a certain way. If you just say do entity recognition for me, it will do it in a certain way. So one model for everything uh, is a possibility here. But these things are constantly improving. So something to keep an eye out on and keep trying new things. So that's where this is pretty advantageous in nature. So that's all from me. I think I'll get to a couple of questions. Just 1 second here. Okay, what is
Nikhil,
fast?
if you want, I can read them
Yeah.
from the chat. It's
Oh,
whatever works best for you.
yeah, Julie, that would be helpful. I think a couple of them were already answered. So,
Okay.
I mean, if you have a track of which ones are not answered, you please help me out here.
Um, so I'm going to be honest, I'm not technical. So sometimes
Okay,
me knowing which ones have been answered is a
okay,
little
okay.
tricky. But I do have a record of them. Hang on one
No
second.
problem, no problem. I can see one. Okay, good to know. Bedrock has just got FedRAMP moderate authorization in USD East and West. Okay, thank you for that news, Bhanu. Very good to know. Something I haven't kept track of recently, but thank you for sharing the information. Akshay Agarwal has a question. You mentioned about a nursing home business use case where recommendations were provided around meeting staffing standard. Can you elaborate a bit on the problem statement or business requirements and which specific problem you were trying to solve regarding nursing homes? Okay, I see. So, Akshay, we actually, this is an interesting intersection that happened as part of AIM. We do policy feedback analysis as part of FAS, and nursing home data analysis as part of the 2567 use case. But there was this one policy that came in regarding minimum staffing standards. I'm a technical person. I wouldn't do justice to the business description of this, but there was this interesting overlap that came in that docket which was requiring comments regarding nursing homes was posted on regulations.gov, and it kind of just overlapped with what we have as part of 2567 and uh, FAS here. So that was just a coincidence, if I answered your question.
Okay, Nikhil, I have another question which I apologize if you did already answer it.
Mhm.
How generalizable would this model be from one rule to the next?
The model, okay, so if we are talking about the FAS models, it would be generalizable because, I mean, if the question is coming from the point of view that the context changes whenever a new docket comes into picture, that's something we have observed is like for some classification kind of tasks, that usually if we are talking about, let's say, identifying recommendations, recommendations have a structure to it that please do things in a certain way, or there is a certain language at least that's used as part of the comments to say that something is a recommendation or agreement. So that's where the context kind of doesn't help as much. You always look, the model can understand the structure of the statement to make a determination about whether it's an agreement or a recommendation. But context, incorporating additional context can help with improvement in the model. So if we see a need for it, that's something we'll definitely incorporate. So that's a open possibility for us. So that's something we have not ruled out for sure, but these models understand the structure of language, so that's where we have seen decent performances.
Okay, how do you determine the right performance metrics for an AI ML solution?
Okay, right performance metrics. So like it depends on where you are as part of your project. If you're in the initial stages of the project, you definitely have a lot of work that needs to be done in terms of collecting the right data, collecting the right test data, and so on. So if you're in the initial stages of your project, having some really rigid metrics doesn't make sense until you collect some decent amounts of testing data and training data in place. And even after you collect your testing data, you can always say that, okay, I want a 95% plus accuracy on it. But it's very critical to understand the fact that your test data has to be well represented. Like it has to be free of bias. It doesn't have to have a lot of features, a bias towards certain features or certain concepts in the training data set. Once those considerations are completed, then it's good to set a decent benchmark that's achievable on data. Using bad testing data and getting good, like really high accuracies on it is not as good as having well balanced data, but generating slightly maybe 5 to 10% less accuracy on it. That good represented data will get you a lot of value, even if your accuracies are not the best. And this is for the initial stage, but as you keep building your feedback systems and additional pieces around your model, you are going to get additional data. You're going to keep analyzing it. So after that, things start becoming much easier in terms, and you get an understanding of the use case also, right? So that's where what kind of metrics you want to set, what kind of data should go into your testing data set, that all kind of evolves as you kind of improve and make your solution better and understand the business processes in a much better way.
Thanks. How do you go about the process of choosing a model to solve a particular use case?
Okay, so this was very interesting. I do have one example associated with this. We have a similarity use case as part of FAS, and whenever you talk about similarity, you would think of context comes into picture. Like you would want to say, like, let's say if it's a car, then Ferrari has to be similar to a car, right? That's kind of contextual concept makes sense when you talk about identifying similar statements or similar text. But in the when we were working on FAS, we realized like the certain use case for deduplication that did not, after talking to the end users and understanding what needs to be done, we realized that we do not need context into the picture here. We can completely go around the context question and go for a more simpler process like TF-IDF or count vectorizer to identify duplicates, and that's what worked best for us and helped us achieve the required goal that was set out for machine learning for that specific use case. And a lot of dashboards were built around this, and it has solved the use case in a decent manner. So that's where this interesting part about choice of a model comes into picture, and the understanding of the business requirements plays a critical role in this. So this was just one example. I hope it helps. I don't have like a straight answer to this, but it depends on what your business process is in terms of that use case, and that is what helps you to choose the right model.
Generalize
Okay.
existing workflows for new use cases.
Generalize existing workflows. So, okay, I did say about the recommendation agreement use case. It's the question is more about the structure of language in as compared to knowledge about the use case. So that's where that generalization is much better in that case. But let's say if we are going for we do use entity recognition in one of our models. So it is trained to identify entities of interest for the specific use case. But if you start using that on some other data, there's definitely going to be challenge. It's not going to identify the right entities. So you you can use the best solution in this case would be to collect additional data and fine tune your model, but that's the effort that would be involved in this. But one thing you can always do, a lot of techniques are available out there where you don't have to train your model from scratch. You have your learnings that you identified things while you have done labeling previously. So those learnings can be carried over to collect data very quickly for the new model. Maybe it doesn't require a lot of data. One very interesting thing about SageMaker models is that you can, I'm not able to recollect the name, but you can begin training from the last checkpoint. So you don't have to do the training all the way, but just the new data that has came in, you use the last model checkpoint to train on the new data. So depending on the use case, the adaptability kind of differs. The effort in adaptability differs. But if the adaptability effort is more, definitely things can be made easier so that it quickly adapts to a new use case.
Okay, how do you ensure your AI ML solutions are free of hallucination, inaccuracies, errors, and or bias?
Okay, that's all. That's been kind of the main question always when you come to an AIML solution. Hallucinations is something that is associated with large language models. I mean, right now, the I talked about a couple of things in the presentation, like using test-driven development or metric-driven development while you use large language models. So that should take that hallucinations are going to happen. So first thing to understand is that hallucinations are going to happen, and as these models improve and a lot of people putting focus on why is this hallucinating, this shouldn't happen, it's going to keep better and better. But until then, the test driven approach and a metric driven approach is what will help. If there are accuracy, there's actually a lot of open source repositories that have come out that integrate with your models and show you metrics about there is a certain hallucination in this problem, or there is the response is inaccurate. So a lot of open source development is going on around this area, which helps you determine the right metrics before you use your large language models. So that's about hallucinations. But how do you ensure the AML solutions are free of inaccuracies, errors, and or bias? There are a lot of tools available out there that can help you with this, but definitely always a qualitative analysis will help in terms of reducing inaccuracies and errors or bias. It's the explainability tools like Clarify. If let's say you are detecting a certain statement, but you can pass that through a Clarify explainability job, and that will tell you what words or areas it's specifically looking at to make a certain prediction. So that will give you an idea of how the model is understanding the data and how it looks at the new data when it comes into the model. So that's where a lot of these things come into picture in terms of reducing inaccuracies, errors, and bias. Of course, the obvious answers are already out there: improving the training, all these things, doing good model training, doing good validation, using right validation processes, and all these things. But I think data is the most critical part in machine learning. So having good data, spending a lot of time on your data will take care a lot of these problems beforehand.
Okay, we have one and then we'll wrap our session. Can you explain the details of integration of SageMaker with Databricks? Does it work with Python only? Does it also work with R and Spark?
Okay, so I'm not the best expert in Databricks ML, so really sorry for that. But I think this question, I think Derek has helped me out on putting the SageMaker notebook into Databricks, so I think he can answer this better. But let's see, integration of, I think so. One thing feel is like usually in the notebooks I use libraries like Sage, like doing a pip install on SageMaker, pip install on datasets. And so I think that can be done as part of Databricks. So the integration shouldn't be a problem. But maybe one thing differently you'll have to do is, let's say, when you're talking to certain S3 buckets, since I am within the SageMaker and the AWS environment, I can talk to the S3 bucket without any additional validation or any keys or anything like that. But maybe once you go to Databricks, maybe that would be different, but I could be wrong. So not the best person to answer this question. Sorry for that.
No, that's okay. I can forward
Yeah.
that question on as well to our CCSQ DNA team as well and see if they can get us any more Databricks specific info.
Yeah.
All right. Okay. So I think that takes us through the end of our Q&A. And thank you so much, Nikhil, for our awesome information today. And our next presentation is going to be in just a couple of minutes, which is a day in the life of a plane with Gennady Sherman. That will start at 3 o'clock and end at 4 p.m. Eastern time, leaving us with only 2 sessions left in our data camp. So be sure you join us in just a couple minutes. I'm going to go ahead and switch out our slide decks. If you need to take a quick break, please do so, and we'll see you then. Thanks.